So now let's move on to our third bottleneck, process timings. Some of you who work in bureaucratic or very large enterprises are probably very familiar with. Something that slows you down, but it's not an issue of congestion, it's a process that stalls you. Imagine you're the only car on a road, but you still have to stop at red lights and wait, 2 to 3 minutes for a green light before you can continue. This happens a lot in the world of software delivery, where processes, timings like change approval boards or security roles or security reviews or funding approvals all happen at a cadence that your team doesn't control. These process timings are derived from the governance and the policies that your organization has deemed necessary. For example, many companies have a change approval board, a CAB policy that has to approve code changes prior to production, to ensure that processes were properly adhered to. If the CAB meeting is held once every 2 weeks, then it doesn't matter how fast you completed the work. You still have to wait for that green light, for that CAB approval. And if your change doesn't get approved in that meeting or even talked about because you've run out of time, then you might have to wait another 2 weeks for the next meeting. It's really out of your control. So it's like waiting for a stoplight. You might get there when the light turns red and have to wait, or you might get lucky and get there just as it's turning green, but you don't have control over that. And the same thing happens with other system policies, security reviews, or funding approvals, any governance or policy, especially one that has a certain cadence. And you have to adhere to that cadence. And even if you improve your flow, you still have to wait for others to give you the green light.
So how will you see this in Viz? Bottlenecks caused by process timings are visible in Viz when wait states, like waiting for approval or ready for sign-off, exhibit mounting current artifact counts over time. A high watermark records the highest value Viz is observed within the selected time frame. Back to the CAB example. For these wait states, you will see a high watermark, and then the fluctuating current artifact counts that will climb towards that high water mark, then go back down based on the timing of the cadence. Artifact counts will start to increase up until the bi-weekly meeting, and then go back down to 0. If things often get put off till the next CAB, then it won't go down to 0. Viz will record the high water mark or max artifact count it observed in your data within that selected time period, so you can compare the current values to the high water mark. Just like the stoplight example, when the light turns red, cars begin to back up. When the light changes, the cars go and the lane clears. Depending on when you look at the intersection, you might see many cars there, or you might see none at all. The high watermark value is a clue pointing to the buildup trend, even if the current count is low. So how do you solve it? If process timings are proving to be your bottleneck, it's worth experimenting on how those timings can be minimized or done away with altogether. Going back to the CAB example, perhaps you can experiment around automating the change approval process. You can collaborate to identify the criteria for what constitutes high-risk changes that do need to go through the CAB, while low-risk changes can be deployed without the CAB review. You can run an experiment for a few teams, make sure it works, and then if it's successful, make it a standard practice. Gradually, you can open up the criteria. So not only are you reducing the wait time for the things you can automate, but your biweekly CAB meeting will also be more valuable. It can focus on complex, non-routine changes that require more analysis.